Hey folks, my name's Nick, also very small. Let me make myself bigger, there we go. Hey everyone, I'm the CTO Protocol, putting a quick video together to give you an update on Tachyon. Show you the latest and greatest of the hardware, a bit of some of the changes we made from the original prototypes, and then give it a bit of a kick-in. We're really happy with the performance, so happy to share that with you. Maybe let's jump in, no point dilly-dallying around. Hey, the magic of an overhead camera. Here is Tachyon, the hero of the hour. This is the prototype that we built. I can, you know what, maybe I'll just switch cameras. I've got this little one that I've been using to show people. Here we go. This is the original Tachyon prototype we built. You know, got 5 antennas on it. You know, a little extensive, but that's what 5G radios need. Different bands, different configurations. We've actually reduced those down on this device here, combining some of the antennas together with external components, such that we can reduce the number of physical antennas. You'll notice the actual Tachyon device has got a physical antenna in the space where I've got a Raspberry Pi 5 here just to give you a few comparisons. In the space where the Ethernet and USB goes, we've installed a 5G antenna. Really good quality antenna. Been very, very happy with it. This is the pre-production antenna. So it is using a flex PCB. It's very similar to the antenna design, in fact, if not identical, but the final version of it will use something called LDS, where we use a certain type of plastic material, and that when put into a bath, electroplates itself with a specific antenna design on it. We're using pogo pins now to connect to this antenna to the base board, so the UFLs of here have gone away. On the original design we had lots of buttons. All those have gone away as well. There's just one button now that's control of things. We had a Nordic microcontroller. Excuse me, I just need to budge my mouse to keep the display from sleeping. It's Nordic microcontroller. We use those a lot on our MCU-based platforms. Really happy with it. Good performance. We switched it out for a TI one. It's actually under the shield now for to keep the RF gremlins at bay. We did that for a couple of reasons. One, we needed a 1v8 because the Qualcomm chipset is 1v8 because it's in the low power mode configurable, and that is the standard that cell phone chipsets use because it's a cell phone chipset. So we switched to a native 1v8 MCU TI. I can't put the model number of it. Happy to share that. The benefits of that, I think, are that the quiescent current is very low, that the power supply draw in general has been negligible with it. And I'll explain maybe a little bit about that later on as we go, why that's characteristics of it. Let me see a few other things we made. We followed the footprint of the Raspberry Pi a little bit more closely to make it compatible with cases. So you'll see this here's got like 2 USB things sticking out. On the actual Tachyon board, the second USB, the USB host, which is for plugging in USB hubs and stuff like that, is recessed because on the Raspberry Pi 5, just happen to have one here, the context of which way my camera's pointing, there we go. Raspberry Pi 5 has sticky out HDMIs on it. In order to make this compatible with boxes, we made this flush so that only the primary USB sticks out. Here's a Tachyon device in a Raspberry Pi 5 case. You can see it fits in very nicely. What else did we add onto this? Wi-Fi antennas on the PCB in the same place. The underside of it is very, very similar. We've got GPS antenna over here. You can add in a very low cost flex PCB antenna for that. Oh, debug board's cool. We altered how this works. There's a little adapter. It just connects to this connector on here. If I can get that in without picking things too much. And that gives you access to the serial port, to the microcontroller, and the Linux root console, if that's what you want to do. Typically, I don't need to access those unless I'm trying to debug some system behavior thing. I typically use a system console of either ADB or just SSH into it because it doesn't have any boot up problems at the moment. So let me see. Battery connector, PCIe Gen 3, 1 lane. There's an extra lane we have on the board. We've been wondering whether actually we should have used a 2-lane connector on it, and then built a flex PCB adapter so that we could have in fact built expansion cards, but maybe that's one thing for the future. CSI DSI, on this board here, they were either DSI or, you can kind of see the silk screen. One was display, one was the camera. And on this one, we combined, so you can have 2 cameras on it, or 1 display, 1 camera. That was a particularly tricky beast, partly because the Raspberry Pi 5 chipset uses a little chip called the RP1. Is this, I guess it's this guy here. I never looked at it in too close detail, but I assume it is. It looks like a big chip though. Anyway, it has a chip called the RP1, which is basically behaving as a PCIe switch, so that inside of that you can have other PCIe devices hanging off it, or you can have some of the peripherals built into that chip accessing to be accessed over the PCIe bus, those being CSI or DSI and things like that. And that chip itself also has the ability for its PHY to use either CSI or DSI, because they're very similar electrically, on the same ports, and just switch the configuration of it. The Qualcomm chip we're using over here is QCM6490. Doesn't support connecting up the CSI and the DSI in the same port with the PinMux. They have dedicated 4 CSI buses on it though. So in theory, because it's made for a cell phone, typically you wouldn't need to switch them dynamically. It also has a DSI in it. So we added in a TI switch chip, so it can switch the high-speed signals either to the DSI or the CSI peripheral on the chip, so that you can select at runtime which comes out of that. That was a mouthful. A lot of work went into getting that bit done. Some of those chips are under these PCBs as well. Got the LED on it. Currently, I don't know whether the light's going to be good enough for you, but it's glowing cyan, which, if anybody knows, particled kind of trademark LED, means that it's connected to the cloud and up and running. And I've also got connected to Wi-Fi. Both of these are connected to Wi-Fi at the moment. We'll go and do a cellular test in a minute. But at the moment, Raspberry Pi is also connected to that as well. So if I jump over, this is the Tachyon device, and it's connected. It is connected to the cellular networks, RMNet, and then it's also connected to WLAN. And then the Raspberry Pi 5 is also connected to the same wireless LAN network. Just before we do that, the way you program this board is you hold the button down. Maybe I'll show you that after I've done the speed test, because there's no point breaking a good demo. Let me run speed test on the wireless LAN interface. So I do have fairly good internet here. I wonder what speed this is going to get today. The maximum I've seen is, maybe it's close to, I've seen it about 420 megabits down. It's getting close. 4 or 5. Upload, I think I've seen it at 660. Yeah. Don't know. Maybe my wife, neighbours are using it. It is bank holiday. What do you call it in the US when we have the day off on a Monday? Oh, Martin Luther King Day. Today is the specific name of the day. In the UK, we've got those bank holidays. Maybe all my neighbours are streaming at the time, but I've seen 660 on the upload and about 420 on the download repeatedly. That is coming from this little chip antenna. Did I put my little camera? So, chip antenna. This thing down here. Remarkable. It's Wi-Fi 6E capable, so it can connect over 6 gigahertz, 5 gigahertz, and 2.4 Wi-Fi connections. I can run the same exact test on the Raspberry Pi 5. Exact same. No parameter changes. They're both connected to the very same Wi-Fi networks. No magic tricks on it. And I think that I pretty much get roughly that. Now I've seen Raspberry Pi get faster than that. So just to be very fair to it, I'll give it another go. I can just give this a second go in case it's going to decrease. I wasn't expecting the delta to be so big. It's pretty reliable, isn't it? It's going to keep going up. Raspberry Pi 5, give it one more go. No. Well, whatever the reason, Raspberry Pi 5 is coming up at just under 100 megabits. I think I've seen that up to 200 to be transparent, but it's a little bit variable. I don't know what's going on with the Wi-Fi stack on that side, but I have had variability around 90 as well, so I think it just depends on how it boots and what it connects to. I say what it connects to. There's just one AP that it's connected to. I set up a dedicated network for this, so I don't know. This guy, pretty good. If I run it again, maybe we'll get a little bit faster again. No. Oh, I guess the takeaway is the Wi-Fi antenna seems to be working extremely well. I'm maybe not going to hit the high T upload speeds of 660, which was very surprising because the upload seemed to be a lot faster. For transparency, the very maximum, I've just remembered now, I have a speed test somewhere, but the very maximum download I got was 720 megabits on it. I completely forgot about that, which that completely blew my mind as to how this little chip antenna could have achieved that, but it is pretty extraordinary. We've been contemplating putting on the UFL connectors on it. These things down here, this board has the UFL connectors on it so that you can put external Wi-Fi antenna on it. Honestly, I think given the performance of it, it seems surprising why you might need to do that. So I think that's still something that we are looking. Maybe we'll just remove the components, simplify the design. And because there's no switch on the RF, you still have to go and solder a solder blob onto it to switch across those antennas. So not convinced that that kind of performance with a built-in antenna is needed. We're going to go out and do a cellular test as well. This antenna currently connects to, I think it's doing T-Mobile predominantly. For reasons unknown, it can connect to AT&T as well. It's got the profile for it. Getting about 110 megabits a second download. And I can't remember it up, maybe 75 up, something like that. It's a little bit slower than my cell phone. I've got iPhone 14 and then another phone down here with the same SIM inside it, but it's not much slower. So I think that's partly a little decision we made in that when I said we combined antennas, we still have two antenna configurations in here, and only one of them can be active at once. So there's some software that has to steer which of the RF feeds, this thing here, gets to go to which of those antennas dynamically, and it's a whole bunch of fuss. Great. Do I have anything else to say? This is the battery pack. I think this battery pack, I'll tell you a test I did. I connected this just to the cellular network. Oh, well, I mean, because it's got a battery pack on it, and just disconnect the USB and it just keeps connected. If you, it's got a little activity light on it that shows you when there's stuff occurring. Maybe I have to, it's blinking, trust me. You can configure that activity light to indicate whether it's the battery charging or whether it's disk activity or network activity, whatever you want to do. It's just a parameter inside the kernel. Let me see, is there anything else? No, what I was going to do was, what I tend to do is I just pick this thing up. Maybe I will switch to the overhead now so you don't need to get seasick too much. Typically, I mean, it just works. I pick it up and I walk around the house with it like a pet. Very recently I've been just throwing it in my backpack, walking around with it. As I was going to say about the battery life, currently the battery was configured, or the device was configured to sleep whenever it can, but not to suspend anything, so just automatically put things into low power mode, a bit like, very much like a cell phone does. The chipset itself from Qualcomm QCM6490 is extremely power efficient because it's a cell phone chipset from the Android kind of 2021 era. This is a way bigger battery than you get inside an Android cell phone. So you can use one of those single cell batteries. This is a Raspberry Pi case with a Muon. I don't know if anybody knows our microcontroller So it's like a Raspberry Pi shaped microcontroller. Probably have one somewhere. I never know where I put these things. I would turn around and be like, aha, but it's not available. Somewhere around here on my desk of things. There's one in here. I use a microcontroller architecture. It also is compatible with Raspberry Pi hats and things like that. This is one of my favorite cases because it has a built-in wall adapter. There's different versions for UK and US. It's basically just a USB-C PD adapter with a short profile, and then you just plug that USB-C cable into your board, and then I strapped an external battery to it. These single-cell batteries also work just fine with Tachyon. We love these 18650 cells at Particle. One of the things we have done, which takes a very long time with this board, is profiling the battery such that you know what the battery power percentage is for capacity. There's also a massive amount of complexity in not using the battery. So a cell phone never thinks that there's no battery connected, and therefore has never had to worry about it. And that means solving and cracking one of the biggest problems there is out there with, I think, single board computers is the USB PD power delivery mechanism, and how you can deal with the state as it goes in and out of that. You know, Raspberry Pi famously uses a proprietary power connector with a 5 volt, 5 amp feed on it that's needed to be able to get the board to supply with its current. And that's been one of the main fun things with us. If you unplug this, then the board is just off. You can just plug this in again. We've got a little button on it. You can determine, I don't know what this is worth, a final camera switch. Let's just go for it. There's a little button on it. By default, it's off. There's a parameter you can set whether it boots up, it's red, and you press the button once, and then it'll flash green as it boots up. At any time you can plug the USB-C in, it will just continue to charge the battery up as to where it is left off. The colors typically mean green's flashing as it's booting. After it boots, it will start to glow green, which means it's operational. And then the activity light also flashes as it's booting up, just to give you a pulse. And then after a while, it will glow cyan if it's connected to the network. There we go. Glowing green, that means that Linux is booted and all of the applications and stuff started up. This is controlled by a user application. It's not part of the kernel. It means that the last app in the setup has run. And then it'll start to connect to the cellular network. It was connected to the cellular network before, but I'm in my basement. I guess, you know, it's super messy, otherwise I would show you around. And I have almost no cellular connectivity. So what I'm going to do is just unplug this. And I'm going to go and jump in my car and drive it around. And oh look, it has connected to the cellular network. Let us just have a look at what that looks like. Oh, because it dropped, I have to reconnect to the device. There we go. I have config. We are connected to. Oh, it has dropped already. Yep, it has dropped. If you go and look at that's the problem with the network quality down here. On my cell phone, I even switched to AT&T so I could get connectivity in my house. It will sniff around to another network and connect to it, but I don't need to worry about that because I'm about to go wild, and I will go into my car, take my laptop with me, and I will tack onto this video some performance tests done just driving around San Francisco, and you can kind of see what the cellular performance looks like. And there's also a super cool feature that I will tag you on after that. But I'll see you in a sec, folks. Bye. Oh, where's the button? Hey, folks, quick continuation from the basement. I just drove out to the spot in the Bay Area. I just don't know if anybody can recognise this from the panorama. I know the sun's in the way. Can't see any planes taking off, if you happen to know the area. It's probably the quickest spot. I thought there would be good cellular connectivity, and because cellular in San Francisco is very variable. Depends on what time of day it is as to how much the network's being utilised, and as much as people invest in more towers, also people invest in better phones. What I can do is I can quickly, am I logged into Tachyon? I am. I SSH'd into it over a WireGuard managed network. So basically, here's the Tachyon itself. I should have shown you that. Sitting, connected to the network. I didn't do anything to it. I just unplugged it from my desk. Extremely freeing just to be able to do that. I could put it into the tree and leave it for 4 days, continually SSH into it, and it would just work just fine. That's without any optimizations on it. Oh, and that's also with running speed tests. I think I was talking before, and I'm talking miles a minute there, but one of the tests I was doing was taking the 3-cell battery pack, running speed test on it every minute. It takes about 30 seconds to run. And it lasted about 3 days on these batteries, which is pretty much doing near constant cellular download and uploading, which I was super impressed with. Okay, let's whiz to, what are we doing here? Running speed test. There we go, it's auto-filled it out. Warp, the terminal I'm using, fabulous tool. Has a great memory, unlike myself. Here we go. Let's see what we're going to get. I just ran this a second ago and I hit 75. Maybe you will repeat it. A little bit lower. Somewhere around 50. If I go and have a look, whilst we're running it, I've got speed test running on my local laptop. And you can see the variability. I hit a 73, a 23, and what am I going to hit now? This is the variability of the download. This time I got 106. If I whack it again, it's very inconsistent, and I'll just run this one again. Let's see if we can get to the height of 100 megabits down. So this is running on the device. So the left-hand pane here, the RMNet data 0. Typically, you don't need to know about the interface, but it just shows you what it can get. Oh, the internet has gone slower on this device. Let me do the trick of the tricks and just keep running it. This time round, 61. Damn the variability of it. Or maybe this is going over the tailnet. I don't know. Let's figure it out. Here we go. Bit better. No, it's going to hover around 25. If I give it one last go. There we go. Back to 50ish again. Anyway. Cellular networking, amazing. Really happy with it. Super convenient for you just to be able to go and plug it into stuff remotely. Yeah, let me see if there's anything else to say. No. Oh, yeah, there's a trick that I was going to show you, but I forgot the other part of the trick. So what I'm going to do is go and grab that, and then I will record just a quick amendment on this. All right, see you in a sec. Folks, I forgot to show you the hat trick. And it's kind of in a curiously precarious position, and I'll explain why. But here's the Tachyon device sitting on my dashboard. You can't probably tell that the LEDs are slightly different color. I'll explain why. Connected down here is a Raspberry Pi to a USB Ethernet adapter. So one of the cool things that this device can do, because it has a great onboard Wi-Fi and great onboard cellular antenna, is it can turn itself into a hotspot. So in fact, I'm connected right now to the Tachyon hotspot. If we go and have a look down here, I'm not actually connected to the device anymore. I guess I must have disconnected. So now I'm connected to the Wi-Fi tether on the Tachyon device, and now I'm connecting to its SSH shell through a WireGuard network that's going possibly to the cloud and back. I don't know whether it would figure out whether it doesn't need to do that. If I have a look at ifconfig, yeah, WLAN 0 set up with a private network, and my RMNet is configured. In fact, nmcli or cnm CLI. There we go. I can't see what I'm typing today. Let's have a look. Yeah, we connected to Qualcomm Wi-Fi onto our hotspot mode with the routing table set up, and that means if I did a speed test from here, I'd be curious to know. Speed test. I don't know why I was doing the network adapter before, because there's only one network adapter, because there's no Wi-Fi around here. Let's have a look. Probably going to get much lower reception because I'm sitting right next to a bunch of residential buildings. And also, curiously, my laptop is tethered to Tachyon, and the tool that I use called Loom streams all the video up in real time, so that it puts it into the cloud. So that's not terrible. That's the on-device. Let's see. It's gonna. Oh, the up will be terrible because it's streaming up. That makes sense. I should have let that run, but I can do the same thing for my laptop because I'm tethered to the Wi-Fi connection, and we should see similar speeds. I'll tell you, where was I on Friday? I was driving somewhere and I had the Tachyon device, I shoved it in my side pocket, and then I kept my laptop connected to it and streamed Netflix, YouTube, and HBO in separate browsers. Wow, download is super slow now. Why is it so slow? In fact, the whole thing's gone slow. It's very possible that my laptop is chewing up as much bandwidth as it can. I'm never sure. I think my computer's set to only do expensive things when it's on Wi-Fi and not when it's tethered to my cell phone, which makes this experience a little bit unreliable. We'll see. Anyway, what I was saying is I was streaming 3 lots of 720p video down. Generally, they were working without stuttering. I thought was super cool. One of the reasons why I was just showing you there we go, 15. Anyway, inconsistent is consistent. One of the things that made me extremely excited about Tachyon is the ability. Not only is it its own independent single-board computer with 8 high-power cores inside it, with a lot of RAM and a built-in UFS disk, super fast disk drive. No need for an external NVMe disk unless you want it. But you can also just plug in a little adapter and provide connectivity to a Raspberry Pi or cluster of Raspberry Pis. And I was in the middle of trying to wire up my, what's the thing that Jeff Geerling's all over these days, 10-inch mini racks. I bought into one of those a while back, so I was thinking to myself, one of these Tachyon devices plugged into that, providing kind of a backed-in connectivity and basic management services to a larger cluster. I was thinking, I could add a camera into it to go and monitor the lights of things. I was starting to get away with myself a little bit. Anyway, it's cool. I think that's all I've got to update for today. Appreciate you all watching along, and feel free to shoot any questions you got into the Kickstarter commentary section. I know Zach, the CEO, is keeping an eye on top of those and will respond in reasonable real time as things pop in. Great, thanks so much. Bye now.